Hi, everyone. Thank you so much for joining us today. We're just going to give everyone a minute or two to hop on and get settled. But in the meantime, if you would like to share your name and where you're joining us from in the chat, I think it's always a super fun way to get started. Louisiana, California, Canada, Alabama, New York, West Virginia, Iowa. Wow, we're really coming from all over. Iraq, Idaho, Ohio. Wow, awesome. Minnesota. Massachusetts, Florida. Awesome. No, thank you everyone for sharing. It's always fun to see where we're all joining from. We definitely appreciate everyone. North Carolina, same here. So yeah, I think that we can go ahead and get started since we're at a minute after the hour. So I'm gonna go ahead and share my screen. So hi, everyone. My name is Lindsay Josephs, and I'm a marketing specialist at OpenStax. And today I am joined by Louise Krompotic from Digital Edge. She is the Vice President of Educational Enterprise. And today we will be presenting on how you can improve student engagement and comprehension with engaging online course content. So to get started, I'm just going to talk a little bit about what OpenStax is. So a lot of you are probably familiar, but if you're not, OpenStax is an edtech nonprofit based in Houston, Texas, and we're a part of Rice University. And like I mentioned, we're a nonprofit, so we're able to sustain our operations due to philanthropic support from foundations like the Bill and Melinda Gates Foundation, individual donations, as well as mission support fees. So anytime an instructor pairs one of our textbooks with our technology partners, we get a small mission support feedback from the technology partner that helps to sustain our work. OpenStax is a mission-oriented organization, and our overall aim is to transform learning so that education works for every single student and is ultimately more accessible and affordable. Since 2012, we have published over 45 free, openly licensed textbooks. And in the process, we have saved students over $1.7 billion in textbook costs. Now, you just heard me say that OpenStax offers free, openly licensed textbooks, but what exactly does that mean? So OpenStax textbooks are an example of open educational resources, or OER. And we have a wonderful definition up here on the screen from the William and Flora Hewlett Foundation. But in essence, open educational materials are any educational materials and resources that are available in the public domain, don't cost anything to use, and don't have any restrictions on them as to how individuals can edit and modify and rearrange the content. There are a lot of unique things about OpenStax textbooks, but we also make sure that, our textbooks follow the standard scope and sequence requirements of their respective courses. Like I mentioned before, we currently offer over 45 textbooks, and we offer these textbooks in the areas of math, the sciences, the social sciences, the humanities, business, and college success. All of our textbooks are written and reviewed by experts in their respective subject areas. And in addition, all of our textbooks go through a rigorous editorial process. So instructors who are using our textbooks, for example, can submit errata suggestions on our website for our editorial team to review. And we make sure to edit and revise our content to ensure that it's up to date and relevant and diverse and representative of different audiences. We edit our textbooks when it's pedagogically necessary. So if there is a major development in a field, we may publish a new edition entirely of one of our books, like we did recently with Astronomy 2E, or we may make just smaller updates to the web version of our textbooks. Overall, OpenStax textbooks look a lot like other textbooks that exist on the market. However, unlike textbooks that aren't OER, OpenStax textbooks are 100% free and are available under an open license. You can edit and rearrange and revise and remix the content to meet your teaching and classroom needs. Here at OpenStax, we offer much more than just textbooks. So each of our free textbooks also comes with free instructor and student resources like LMS course cartridges, test banks, and PowerPoint slides. In addition, we also offer free webinars like this one and free articles on our blog on topics like strategies for teaching in a remote environment and tips for using our resources in your classroom. We also offer OpenStax Tutor, which is our low-cost courseware platform, as well as our support center, which is a really excellent resource to turn to get answers to any questions you may have about what OpenStax is and how you can use our resources. Lastly, we also offer OpenStax Tech Scout. So we know just how challenging and time-consuming it can be to find courseware, online homework, lab simulations, etc. for your course. So we decided to streamline this process through OpenStax Tech Scout. So essentially, this is a searchable tool on our website where you can filter for different courseware and educational resources that align with each of our textbooks and that also meet your diverse and individual teaching needs. Like I mentioned before, one way that OpenStax is able to sustain our operations is through our partnerships with learning technology companies like Digital Ed. So Digital Ed offers low-cost, high-value options that helps to support instructors and students. And as an OpenStax ally, Digital Ed ultimately enriches the OpenStax experience for all and helps to provide us with the financial support that we need to keep our books current and accessible for all. And going off of that, I am now going to turn it over to Louise from Digital Ed.
Wonderful. Thank you very much, Lindsay. I'm very excited to be here, and thank you everyone for joining us today. So today, my talk is really going to be about improving student comprehension with engaging online course content. We are a partner with OpenStax, as Lindsay mentioned, and what we have done is we have used our online courseware platform, Mobius. We have brought the OpenStax titles into Mobius and then have added additional elements to that to really help with online learning for students and to really help improve their comprehension. So over the course of this sort of webinar, what we're going to do is sort of dive into some of the ideas of offering courses online. What types of things can we do and what benefits can result based on using that. Really, I'm going to kind of focus on the first two elements here, the student engagement. How do we keep students engaged when they're remote or in an online environment? And how do we also help to improve their understanding and their comprehension of topics? And then over the course of the session, we will discuss a little bit about how having the right tool and using the right tool and the right content will really enable instructors to customize their lessons to fit specific needs and, you know, decrease the marking requirements, but also provide additional sort of learning opportunities, assessment opportunities, and without necessarily having to reduce the assessments that you use in order to maximize your time. So the first piece that I'm going to talk about is really about student engagement. And when I talk about student engagement, the items that I'm really thinking about are, you know, how do we engage, allow the students to explore, and really excite them in terms of what they're learning. we really want students to be an active participant in their classes. We don't want them to just be reading or just be listening, but taking part in that learning process. So we want them to be answering questions, working with interactive learning objects or visualizations, experiencing a class where they can progress at their own pace, and also offer different types of assessment and ask questions in different ways so that students can either work together, can discuss concepts, but also learn different elements. So the first thing that I really want to talk about is sort of the active learning, sort of trying it piece, the practice piece. So every course has materials that students have to learn. Traditionally, at most higher educational institutions, this has been done through lectures or videos, and students are expected to watch or listen, and then after lecture, spend additional time to really understand the material. So, textbooks like OpenStax will provide information for students. They will provide examples, and then the hope is that they will try some examples on their own to make sure that they understand the concepts. Most students that I talk to really sort of talk about how they don't have time to do examples, or maybe the instructor has provided so many examples that they just don't feel that they can get through them all. But what you can do in a tool like Mobius is to provide that immediate chance for them to try an example. So you can show them the example and then you can say, try it. So here, while they're still reading, they can put in an answer and check to see how they did. A lot of schools that use our platform along with the OpenStax content will create sort of participation marks so that students are more tempted to answer the questions, which really help them learn. The other benefit here is that you are able to get reports on which students are actually trying the examples, or which examples are the ones that are being most used. And all of that information then helps you as an instructor improve your course down the line. The other thing that I wanted to talk about here is just sort of presenting the material in different ways. Putting material in different ways really sort of not only provides different methods for students to learn material, but also when you do that and you include things like videos or interactive elements, you still want the students to be able to interact with them. Here we have an example, which is what we call in Mobius an interactive narrative. So it's similar to a video. There can be an audio track. You can it can go along, you can highlight certain areas, you can talk about different things. But one of the key benefits is that you can also pause this video and ask a question. And now this question can be randomized so that students have read through or watched a video, read through the material, and now they're working on the problem. So they can try it, they can immediately see how did they do, and get responses, immediate feedback, get information on how they could have worked on the problem. And then you can have this try another, the ability to randomize questions so that students have the opportunity to practice multiple times until they feel comfortable with the course material. And once they are comfortable with it, they can then press continue. Another idea in terms of sort of really leveling up the student engagement in a course has to do with sort of group work, or the idea of gamification, right? So how can you get students to work together in a STEM subject in an online environment? And one of the nice benefits of using an online technology tool is that you have the ability to really think about assessment in a different way. What are different ways that you can ask questions? How can you, scaffold questions together to get students to be working together more closely? At the University of Waterloo, who is one of our big customers, what they did during the pandemic was they wanted to actually do some group work. Students were all remote. they weren't able to get together and meet each other. So the prof in one of their calculus courses, what he decided to do was actually create an escape room. The idea behind the escape room was that students would be able to work in groups. They would talk about the questions that are here. And the idea was for them to get through this series of questions and ultimately escape the room. But it allowed them to discuss mathematics. It allowed them to get to know some of their peers, as well as to see some of the different types of questions that can be asked in a calculus environment. So here, just as an example, they had a picture of one of the hallways in one of the buildings on the University of Waterloo campus. And, they set up a scenario. So something is happening, and now you get to this lab. And in this lab, you have, this keypad, and there's, you look around, you see this keypad, but you also have to enter this 5-digit code. And underneath that keypad, there's a piece of paper that has a graph and instructions. And so the instructions are code digits given by inputs where the function is discontinuous, followed by inputs where the function is non-differentiable. So now you can see this isn't just a standard differentiate this function type of question. It's really sort of getting at some of that higher learning, right? And thinking about, okay, now you're looking at this graph. What does it mean for a function to be discontinuous? So what are the points where we would say if this function is discontinuous? And then where would we say this function is non-differentiable? And figuring out what are those input points and what is the code that we would put in. So these escape rooms that were implemented, the prof at the end of the semester actually did a survey with the students to see how did students like doing the escape room. And one of the comments that they got was it was harder. The questions were harder, but they did feel that they got a chance to discuss and to meet with people and to work on something. So it was, again, getting them involved in the learning rather than just reading or listening to material. The other thing in terms of using online technology to supplement the material that OpenStax provides enables you to put in things like this, where it's the epsilon delta idea of limits and what happens, and having sliders that allow you to really visualize what does this mean mathematically. Here on the right, we have the series expansion around a given point, and trying to get a sense of, well, if you have the order of expansion is 1, it's going to be a straight line. If we move up to 3, then it's going to be this type of curve, and it gets closer and closer to the sine curve that you're trying to get towards using a series expansion. But again, if you explain that to a student, is entirely different than them being able to use the sliders to see what's happening. And when students see what's happening and have control over that and can enter in an expression to see what happens, they get a much better understanding of the underlying problem and the underlying concepts. And now when I talk about improving student comprehension, one of the things that I'm talking about here is, we've talked a lot about the different features and functionality that you can add into your class in an online environment that you may not have had the ability to do previously. But let's also think about, well, how do we know and how do we make sure that what the students are learning is really going to be better? Can we improve it? Can we make it better than what they can traditionally do? In STEM subjects, one of the main key elements, I should say, is really for the students to actually learn by doing. They need to actually get in there. They need to solve an equation. They need to work with an expression and factor it. They need to differentiate. They need to learn the steps and the process. So they need to practice those concepts. But not only that, there are times as an instructor, when you're talking to your students, that you want them to have what are called desirable difficulties. You don't want to just give them questions that they can answer without even thinking about it, or it's just a process that they write down. You want them to actually have to pause and think a little bit about something, to incorporate different topics and different concepts together to solve a problem, right? And then maybe to apply what they've learned to different situations, because being able to do that is that different level of knowledge. So how can we sort of allow students to have these desirable difficulties, but not get them, so that they're frustrated and want to give up? We want to sort of balance that a little bit when we're dealing with online courses. And the last thing that I've included there is really on spacing and interleaving, and providing students opportunities to see concepts multiple times, and in so doing to actually retain the material longer. So in STEM subjects, one of the, it's really important for students to practice the concepts, right? We want them to, for example, solve an equation, or we want them to enter an expression or graph an expression. And so any tool that we use in STEM subjects really need to have a variety of question types that are available, so that you can ask the questions in different ways, but also so that students get used to entering answers in different ways. So it could be multiple choice, but could be a numeric question, or formulas, or graphs. We want them to experience all of the different types of answers that you can get in a mathematical or in a STEM-based concept. And equally important to that is to have an online tool that is able to automatically grade these questions and accept student answers appropriately. So this particular example that I'm showing here is provide an equation of any line that passes through a given point. So here, this just shows a couple of different answers that a student could enter, both of them being marked as correct, because with a nice math engine, a powerful math engine behind the platform, you can actually ask questions that are outside of the standard. So you don't have to say, does this equation y minus 2x equals 0 pass through this point? That's a yes or no question. Or you could ask it if you gave them the point and the slope, for example. Then there's a single answer. Here, it's asking a question that's a little bit different, because it's asking them for an example. There are multiple right answers here. And when you have a math engine behind the platform, you're able to ask this type of question and then get the math engine to determine whatever question or expression or equation the student has entered. Is it one, a linear function, and two, does it pass through that point? So now we're going to get the system to do the mathematical check to make sure that what the student has entered is correct. And it just opens up a wider range of questions that we can ask as instructors for our students. And now the other point about student learning, there are going to be times, right, when students are learning a concept and they have a question. So here's just a simple question, like, what is the 13th term of a given sequence? Now, maybe the student doesn't quite know all of the steps to solve that, right? Or maybe it's a question that is more pulling in a bunch of different concepts for a student to actually work together and has to apply a bunch of things together, but maybe they don't know how. So in an online learning environment, it's really important to be able to support the students' learning. Here in Mobius, what we have is a way of taking the student through step by step through the problem. So for example, in this particular case, if the student gets the question right, they can just move on. Okay, they got it, they knew, they can move on to the next question. But if they get it wrong, you can actually provide them with step-by-steps. Okay, so now we're talking about a sequence. What is the common difference? What is the first term? And then what is an expression for the nth term? So you're actually sort of talking the student through the process, and then they can answer the question. So this is super helpful for students, both who may be working on an assignment or working on some material at a point in time when you as the instructor are not available, but also it's something that they can go back and reference as they go through. And of course, when you're using an online tool, especially in a STEM setting, you definitely want to have the capability of randomized questions. So here you can have an algorithm that generates a new set of values for all of the variables that you outline in your question. And then these variables can be used in the question text, in the diagram, in the fully worked out solution. But also in a system like Mobius, it's not just the number. So you can generate random questions with different numbers. You also have the ability to do things like create a question pool. So I know some instructors like to have the ability just to have the numbers change and have the rest of the question the same so that every student gets the same question, but with different numbers. You also sometimes want the ability to have a different context in the problem. You want to use a different problem. So it's testing the same material, but it's a different type of problem. And so in Mobius, you can have these question pools and then swap out or randomly select a given question for a given student. And as well, you have the ability to randomize things like words that are being used or strings and sentences that are being used as well, so that you can really have that ability to change the question up for students. And if you got it in your lesson, like in that first example that I showed a long time ago, you have this try another button. So as the student works through, they can do their question, they can check their answer, see how they did, but then they also have the ability to try another. And as I talked a little bit about desirable difficulties earlier, right? So standard questions that we do really allow students to practice concepts that they have, right? And so a question like this, so this is coming from the OpenStax calculus book, for example. So here, use this graph to sketch a graph of f prime. And so this is sort of a standard question that you'd see in a calculus textbook in terms of, does the student understand what the derivative actually means, what it looks like? So maybe they know how to take a derivative, but do they understand what that actually means? Can they visualize what that means? And so this question is a great question just for the students to work on, to try to answer. But sometimes, like I said, providing a question that, you know, really sort of gives them more to think about is really helpful. A lot of times when I talk to instructors and students, what happens is the examples that students are given for practice are all sort of standard questions. Can you apply the specific process or concept that's been taught? But what then happens is come exam time, they're given a question where they're expected to apply that concept and maybe apply that concept along with other ones. And, you know, really, it's almost a muscle that students have to actually try and use in order to be able to answer that. So why are we not providing these opportunities for students in a more formative setting within a lesson so that they can really get the sense of, oh, I can pull pieces from different areas to solve this problem. And I wanted to show this other problem. This again comes from one of those escape rooms that I was talking about. And so this one, you have a storage closet that is, that again, it's locked, there's a keypad, and you have to put in a code. And then the code with numbers, or sorry, but the keypad is numeric. So now there's this picture. And so the first graphs are labeled A to D, the second graphs are labeled 1 to 4. The graphs must be related in some way, and how. So in this particular case, we're not actually telling the student it's a function and its derivative. We're not telling them that information. We're leaving that for them to determine. So now, again, think of a group of students who are working on a project or this particular question, looking at these graphs and having conversations about, well, how do they relate? How could they possibly relate? And having that conversation and then working together to determine, oh, well, could it be the function and its derivative? Well, if that's the case, which are the ones that match together? And here, if you know the code is A, B, C, D, then which of these ones would match to that? And being able to enter that code and then move forward. So again, we're providing the student with additional learning opportunities outside of just putting in an answer or putting in a number that they may have gotten in doing a particular process. And finally, when I think of spacing and interleaving, here we have the idea of you want to introduce the concept more than once, right? You want to study information more than once. I think most of us as instructors have experienced the case of a student, maybe taking math in first semester of grade 12. And then when they come to university or college, it's been a year. It could be over a year since they've seen a particular concept. And with that timing difference, the student has forgotten a lot of information. They may, once they start to review it, they will pick it up more quickly, but they still have lost a lot of that information just because they haven't used it. And one of the things that learning theory often talks about is being able to do this spacing and interleaving so that students are returning to concepts, but also you can provide different contexts for similar problems. So it's material that they've covered before, but now we're asking about it in a different way. And that just provides from a psychology point of view, it provides different paths for students to get to the same information. The other thing that people often will do is maybe quick check-in quizzes, a quiz that says, okay, so here's something that you should have learned last class, do you remember it? Or here's something that we covered a month ago, do you remember it? And it's just, those can be just quick formative assessments, either before your class or right at the beginning of your class, just to get a sense so students are used to knowing that they need to look back. A lot of times, content in STEM courses are, here's unit 1, we've covered that, now here's unit 2, we've covered that, now here's unit 3. And it's really important for students to not only learn the material, but also to be able to refer back to that and to have some additional information for later on in their courses. Now, throughout the rest of this presentation, I really talked a little bit about some of the things that help students, but also will help instructors, right? Being able to have those randomized questions, being able to ask questions in different ways, being able to add elements into your courses. And there are a couple of additional pieces that I really want to talk about from the instructor point of view. And then I'm going to ask to some of the additional questions that people have asked in the chat and in the Q&A. For instructors, I think it's really important to find a tool that enables configuration and customization of the content so that you can give your class your way, right? Having the randomized questions and automatic marking is, really gives you the ability to offer students practice and assignment opportunities, but also it gives you opportunities to work more directly with your students on key topics. And then looking at the results and the analytics from these assignments and the material that you provide to your students really enables you to focus on areas of need for your students, and then using that information to improve your course material. Here's just a couple of examples, just a simple example of class organization. On the left, the class has been set up as here's a lesson, now here's a quiz or an assignment. Here's another lesson, here's another quiz or assignment. And for some subjects, that's probably the right approach for that particular topic. On the right, sorry, the other one was on the left. On the right is an example of more of a textbook type approach, where maybe you have all of the lessons for the different sections of the textbook, and then you have an assignment per chapter or an assignment after every few lessons. It's not a one-to-one correspondence. And in some cases, you may want your instructional material in one place and to have here, like at the bottom on the left, bi-weekly assignments. You could have your assignments separated out from that instructional material so that the students, if they are looking for their assignments, they know exactly where to find them. So having a tool that allows you to customize your material is very important. As you are teaching to a specific set of students, you're teaching a specific topic, and there may be some differences in how you want to approach that. So making sure that you have a tool that enables that is really important. And finally, having a virtual environment has the potential to capture huge amounts of data. So not just how the students are doing on the assignments, right? Most systems will allow you to do that, but also how are students navigating through the course itself, right? Where are they spending their time? How much time are they spending? And when are they spending their time? And all of this information, because you're getting a data stream of this information, can actually be available so that you can look at it and sort of see what's happening with your class and with your students. As well, you can look at things. So here on the left-hand side, I'll start with that, where it's really just showing some usage patterns. And so, from in a typical class, if assignments are due on, say, a Monday, or assignments are due on a Wednesday, there's going to be more usage on a Tuesday, right? Some students, will leave their assignment to the last minute. But knowing where the usage patterns are from your students, even during the times of day, just helps you to plan and to work things for your students. On the right-hand side here is more drilling down a level. Let's look at the assignments and the questions. So you can actually, in a given lesson or assignment, look at which questions are students spending their time on. How long did it take them to answer certain questions? Which ones did they get right more often than others? And really that just feeds into information for you to be able to then sort of realize maybe there are a few questions that students weren't able to get right at all. Well, which are those questions? And now let's think about why, and be able to then, maybe it's a concept that is a little bit more challenging. And so do we need to add some additional questions on that or some additional explanation for students? A couple of our users, what they've done is they've used this analytics, and then in areas where they see students struggling, they can embed a video into the lesson as additional explanation to really help students with the concepts that were a little bit more confusing or harder for them to learn. So at this point, I'm going to pause. I went through this pretty quickly, but I wanted to have a lot of time for questions. And I see that there are a couple of questions here. So one question was, what is the math engine that is used underneath of Mobius? And it is Maple, which was answered in the chat. Another question was, is Mobius free? And so no, Mobius is not free. It's based on a per student basis. And so what we have done is we have taken a lot of the OpenStax text material. We have brought that into Mobius. We have added in questions, the inline questions, as well as end of section and end of chapter questions that are all algorithmic and have full solutions. And then people pay to access Mobius for a given year. So the pricing is per student per year. and students are able to access as many courses as they need to during that year. Now, somebody is asking as well, could the same level of interactivity in Mobius and Maple be achieved using H5P interactive content and web work problems? And so the, there are a lot of tools that are out there and available on the market. Absolutely. Mobius allows you to incorporate that power of Maple, the power of the mathematical engine, the flexibility of the system Mobius itself, as well as the support that is offered with the platform and training that is offered with the platform, and the content from OpenStax, which we have brought into the platform. Another question, how did the creators obtain funding to include the interactive content in their open textbooks? So I'm not sure of your question, so I'm going to answer your question, but then please let me know if you have a follow-up question. So Digital Ed as a company, what we did was we have this partnership with OpenStax so that we can bring in their open educational resources into Mobius. We have then, as a company, put in the investment to create the inline questions, all the randomized questions that are used at the end of sections and end of chapters, as well as brought in interactive elements that have been created through Maple or through other third parties that we've then incorporated into the platform. Now, external teams that are creating content. So Mobius has, the Digital Ed has created questions, but we do have additional teams that create questions and instructors who create their own questions or who maybe have their own content that they want to bring into the platform, and they want to use the power of Mobius with their particular lecture notes that they have created. So your question there, can also be answered in this way, in that some instructors have applied for grants for their particular material that they wanted to put their material online. So they have applied for grants, and they've applied for the ability to have some time from teaching in order to actually create the course content that they're going to use at their particular school. And then there are some instructors who are doing it sort of in tandem with an instructional design group. So some universities, and more recently, we have seen a lot more universities have instructional design groups. So as they want to move courses online, the instructors will work with the instructional design group to help them get that course online and determine which questions they want to build out online. Let's see, are there any other questions that people are looking for? Who owns the intellectual property of the content that instructors create? So that's a fantastic question. In Mobius, when we bring in the material from OpenStax, their material is either CC BY, so it's Creative Commons, and you have to put in the attribution so that but they can be modified and shared with others. So that's the OpenStax material. They also have some material that has a slightly different licensing, but that you can bring into the platform. So that material, the copyright is still owned by OpenStax, but they've made it available for other people to use, modify, and share. We also, inside of Mobius, have material that was created, for example, at the University of Waterloo. And that material is also owned, the copyright is owned by the University of Waterloo, but they've also given us permission to share that with others, and other people have the ability to modify that and use it in their classes. If, as an instructor, you create your own material, your own content material, that IP, that intellectual property, is yours. And so you have the complete rights to it. We have, with some groups, actually worked on content distribution agreements where we can make that content available to others either freely or for a small fee. And that is something that we have done in the past as well. So then I had somebody who asked about the cost in terms of just clarifying. So there's a per student cost for Mobius. It's a per student per year cost. And so when you purchased, basically an institution would decide to use Mobius in a particular course, and a student would, and then a student would come in and either the institution would pay for X number of students, or we have a model where the students can pay. Again, students can pay for their particular access, and they would have access for a year. And that would be however many courses that student might take in Mobius over the course of the year. So if they, for example, take a Calculus 1 in the fall and Calc 2 in the spring, those two courses would be that one price within that year. Sorry, I'm just reading. There's another question here. Specifically thinking about open calculus textbooks that a faculty member has created and a pool of web work questions by another group. Is there a way for this group to tap into your, or do you only work with Mobius users? So in general, at Digital Ed, our platform is Mobius. So when we are looking to support users who are creating content and creating questions, that we focus on people who are putting it into Mobius. Obviously, we can have a further discussion just to talk about your particular project if you would like, and we can get back to you sort of after this webinar and have some conversations. All right, and Christy, I see that you're asking about the price. So the standard price for Mobius is $35 per student per year. And like I said, that covers any number of courses over the course of the year. And you have access to the starter bundle of content, which includes the OpenStax titles that we've put into the platform, as well as additional material that has been developed by the University of Waterloo. So I will actually just jump into this example here to just show you here. This is our starter bundle content, and hopefully people can actually see this particular screen. I was sharing in a different way today. But here you can see the wide variety of content, everything from college algebra, well, developmental and intermediate algebra, college algebra, up through calculus sequences, differential equations, financial math, statistics, as well as physics and pre-calculus. So you can see there's a wide variety of material that is available here that you can use and then build your own content on top of this, or to combine this material together for your own course. And then I had a question here. If we use a question created by the University of Waterloo or from an OpenStax textbook in an online test or an exam for our course, do we need to add their authorship? So for the University of Waterloo material, definitely not. The material is, as I've said, you are able to use that material how you want to use in the context of Mobius. So as long as it's within Mobius. The OpenStax material, for all of the OpenStax titles, what we have done is I'm just going to jump into a particular lesson, for example. You will see at the top that there is a reference to the OpenStax title that students can go to. If you're using a question from the OpenStax material in an exam, you don't need to use the reference, because we've covered it here within the course material. All right, any other questions today? No? So another question, what is the startup cost to get Mobius other than the per student price? In general, Christy, it's the per student price is the model. So what we do when an institution decides to use Mobius is we will set up a site for your institution. Instructors have access to that for free. Instructors are not required to pay a fee to get into Mobius. Then we do some training to help you set up your courses and show you how to set up your courses. And then your students, either the institution would pay for a batch of students, or the students can pay individually for their access. Another question, does this integrate into most LMSs? And yes, it does. So we actually follow the LTI specs. And so we can actually link to any of the main LMSs that are out there. You can do either a link to the class homepage where you just have them coming into Mobius, or you can actually link directly to activities and then their grades will be pushed back into the LMS. All right, I think that's the end of the questions at the moment. I will just wait a minute in case there are any other additional questions. I'd like to thank everybody for your time today. This has been fantastic. And I love the number of questions that have come in. If you would like some additional information, we will do a follow-up just after this webinar and provide you with some contact information so that we can then reach out to you and have some follow-up conversations.
Thank you so much, Louise, for a fantastic presentation today. I know that I certainly learned a lot, and I thought it was super engaging and interesting, and I know our audience members thought that as well. So thank you so much. And thank you everyone for taking the time out of your day to join this webinar. We all really appreciate it. All right, on that note, I think we can go ahead and end the webinar. Thank you, everyone. All right, have a good day.
Thank you. Bye.